This lesson is about the asset management fundamental of value. You will be introduced to the asset management principles related to value and how those tie into the discipline of asset management, both in and out of the Air Force. Value is a fundamental concept in asset management because it underlies the definition of an asset. Per the International Standard on Asset Management, ISO 55000, an asset is an item, thing, or entity that has potential or actual value to an organization. In terms of asset management, the Air Force Civil Engineer enterprise is concerned with Air Force real property assets. Note that if real property ceases to add value to the Air Force mission, they are no longer assets, just liabilities that should be liquidated for their financial value. Asset value can be tangible. You can sense or measure it, like electricity generation or water delivery capability. It can be intangible, meaning that it's impossible or difficult to measure, like the potential value of having an emergency operations center. Value can be financial, like the total operating cost or plant replacement value we assign to our real property infrastructure. Finally, value can be non-financial, like facility space or ramp space. Given that all assets have value, otherwise they're just liabilities, how much value does an asset have relative to all our other assets? How do entire systems or portfolios of assets compare to each other? In the Air Force, infrastructure value should always tie back to the mission. In this lesson, you will learn about the asset management principles that connect the dots. The objectives for this lesson are for you to understand the value-added level of service principle and the total cost of ownership principle. At the conclusion of this lesson, you should be able to perform these samples of behavior. First, we'll talk about the value-added level of service principle. Assets exist to deliver services and goods that are valuable for mission execution. For each mission, there's a minimum level of service below which a given service is not perceived as adding value. Typically, we define the level of service to be the output of an entire system or portfolio of assets, because that is what the mission owners will actually experience. For example, consistent and quality water does not just rely on the faucet it comes out of, but an entire system of pumping, treatment, and delivery infrastructure. If comfortable, safe, and functional facility space is the level of service you require, you should measure that across your entire portfolio of facilities to understand the mission impacts. The value-added level of service principle tells us that individual assets within the system or portfolio are only as valuable as their contribution to the level of service. A single point of failure within a utility system might be highly valued compared to more expensive components that have redundancy. The value-added level of service principle drives us to change the way we operate from a condition-based asset management approach to a level of service-based activity management approach. That's because managing the condition of individual assets is not good asset management, because you have no way of knowing if you're spending money on the most important asset. To produce the target level of service within our budgetary constraints, we need to look at all the infrastructure that goes into producing that service. Understanding how each asset contributes to the overall activity allows us to understand its relative value and ultimately guide our investment decisions. Let's look at how the Air Force determines the relative value of facilities. The Air Force, as well as other federal agencies, use a mission dependency index to discern the relative value of facilities. As defined by the Federal Real Property Council, mission dependency is the value an asset brings to the performance of the mission as determined by the governing agency. We determine, the MDI, based on the facility support to its occupant's mission and to others' missions across the installation, command, and the Air Force. MDI scores are calculated on the basis of responses to 4 questions. The first 2 questions evaluate the intradependency of facilities, structures, and utilities used or controlled by each functional area. The first question focuses on the interruptibility of a functional element. Interruptibility is measured in terms of the amount of time before mission capabilities are impacted. The leaders directly responsible for the operation or service provided are asked to respond to these 2 questions. MDI questions 3 and 4 evaluate the interdependency between each functional area and other installation functional areas providing essential operational support or services. Question 3 focuses on interruptibility of operational support or services provided by other installation functional areas. Interruptibility is measured in terms of time before mission capabilities are impacted. Question 4 focuses on the ability or difficulty to replace or replicate the services with another provider from any source. Before you panic, I'm just showing you the scoring model that Naval Facilities Command, or NAVFAC, developed based on the 4 questions so that you get a general idea of how it works. You don't need to be able to do this math. Both intradependency and interdependency questions are scored based on a predetermined matrix, and those scores are put in a formula to arrive at an MDI between 1 and 100. Each federal agency that uses MDI adjusts these matrices and the equation to calculate a 1 to 100 score from the 4 questions. The result is used to prioritize investments and show facility priorities across installations, commands, and services. For more detail, the Air Force also has the Utility Dependency Index, or UDI, to score infrastructure segments within the overall utility system. This helps us understand the relative value of each segment because a utility system is tied to just one MDI. Now that we have discussed the value-added level of service principle and how MDI is used to approximate facility value to the mission, we will move on to the next asset management principle that uses value to inform investment decisions. The total cost of ownership principle states that there exists a minimum optimal investment over the life cycle of an asset that best balances performance and cost, given a target level of service and a designated level of risk. For example, we require a very high level of service from our airfield pavement at Air Combat Command bases. So that means no structural issues, minimal surface distresses, and minimal foreign object debris. This drives a very high initial investment in high-performance pavements and consistent operations and maintenance costs such as sweeping and rubber removal. This concept is scalable based on the value-added level of service principle from the system or portfolio level to the maximum asset risk and minimum asset performance. Again, this will depend on how much the asset impacts the overall risk and level of service of the system or portfolio. For example, the runway and primary taxiways are more important to the overall airfield level of service than secondary taxiways and aprons. Sometimes we don't invest in our infrastructure as much as we should because of budget cuts and competing priorities. Whether we're aware of it or not, suboptimal investment will lead to infrastructure degradation that increases risk and decreases performance. The decision maker needs to understand these impacts in order to conduct asset management effectively. As the asset management practitioner, you should be able to communicate when we have busted our risk and performance targets and suggest courses of action to rebalance the scales or manage expectations. I have sketched out this balance beam as being 1-to-1, but the impact of investment on risk and performance will be different for every asset class and system and there's no formula that fully captures these relationships. As an asset management practitioner, the takeaway from this balance beam is that you should be able to make investments that decrease risk and increase performance to achieve your value-driven targets. These investments range from preventive maintenance to capital improvements over the life cycles of the assets. This will be covered in the life cycle lesson. Additionally, methodologies for determining life cycle investment requirements are covered in AFIT's WMGT 400, life cycle cost estimating. The total cost of ownership principle drives us to make the smallest investment that keeps us within our risk and performance targets. After all, if we can avoid unnecessary spending on the wrong assets, we can get more value out of the assets that truly need investment. The Infrastructure Investment Strategy, or I2S, signed by the Secretary and Chief of Staff of the Air Force, acknowledges that we've been underinvesting in our infrastructure and taking on too much risk for the past 2 decades. Civil engineer squadrons have been feeling this pain in terms of emergencies, utility outages, huge work backlogs, and degraded infrastructure performance. The good news is the I2S tells us to reset our values in the Air Force. Through asset management, we want to achieve adaptive, resilient, right-sized, and fiscally sustainable infrastructure. This requires investment in the assets that contribute the most to our desired level of service and getting rid of our liabilities. It also tells us that our risk tolerance and required level of service should be focused on assuring combat readiness, lethality, and airman resilience. To review, I started by introducing the value-added level of service principle. That is, assets exist to deliver services and goods that are valuable for mission execution. For each mission set, there's a minimum level of service below which a given service is not perceived as adding value. Then, the total cost of ownership principle tells us that investing in each one of these assets will be a unique balancing act between cost, risk, and performance, based on how the overall system works, how important the individual asset is, and what overall level of service and risk to mission is acceptable. Together, these 2 principles guide asset management practitioners in determining value from our assets and using that determination to make informed decisions. In this lesson, I described the concept of value in terms of 2 asset management principles: determining asset value at the value-added level of service principle, and operationalizing value with the total cost of ownership principle. Now, you should be able to give an example of a mission-driven level of service. I've provided a few, but you should be familiar enough with the level of service to provide your own example. Explain the relationships between asset value, infrastructure system or portfolio value, level of service, and the mission. Remember that level of service is usually defined as the output of the system or portfolio as a whole. Identify the Air Force Civil Engineer Enterprise tool for assessing the value of facilities. This is the Mission Dependency Index, or MDI. It will come back later, so make sure you understand it now. Describe how asset value impacts the optimum lifecycle investment in an asset. More valuable assets will likely require more risk mitigation and higher performance. Thus, they'll require more investment. Generalize the relationships between infrastructure investment, risk, and performance. Remember my balance beam. When you invest, you improve asset condition. This reduces risk and improves performance. If you review the lesson again but would like additional assistance to understand these principles and perform these samples of behavior, please reach out to your course director. This concludes the lesson on value, but we will continue to reference the concept of value throughout the course.